Okay, so here I've got gear A starts spinning with an angular acceleration given. I'm trying to figure out the angular velocity and angular displacement of gear B at 2 seconds. So what I'm going to do is I'm going to first find the angular velocity and displacement of gear A and then use the gear ratio to figure out what's going on with gear B. So we're going to start with some calculus. We're going to do an integral to go from angular acceleration to angular velocity. And again, that angular velocity is going to be d omega equals alpha dt. That's just alpha equals d omega dt kind of split apart. And again, we're going to integrate both. Starts at rest when time equals 0. We'll go up to some arbitrary time, go up to some arbitrary, we'll call it omega a, because it's the angular acceleration of a. Okay, so again, knowing that alpha equals 450 t squared plus 60, and again I'm going to go from 0 to t on this guy. I'm going to go ahead and do that integral. Now the left side will just very simply be omega a, and the right side then becomes 150 t cubed plus excuse me, not 60t, yeah, plus 60t. Okay, and that's the equation as a function of t. Now, of course, plugging in t equals 2 seconds, I can find that omega a at 2 seconds equals 1320 radians per second just by plugging in t equals 2 into that. Now, what I'm going to do is I'm going to do another integral because, again, d theta, okay, equals omega dt. And again, I'll integrate both of these. Again, they both start at 0. This one goes up to some time. Again, we'll leave it like that. We'll plug in 2 seconds in a little bit. And this one will go up to some theta that we'll call theta sub a. Again, plugging in what I now know about, I guess I could call this omega a. And I'm going to get the integral from 0 to t of 150 t cubed plus 60t. And again, that's times dt. So the left side of this equation is very simply theta a. The right side then becomes 37.5 t to the fourth plus 30 t squared. Again, plugging in 0 goes to 0. Plugging in t gives me that. Okay. Again, now I can plug in t equals 2 seconds to find the angular position of shaft A, which will be 720 radians. Okay, now that I've got the angular velocity, angular position, I'm just going to use that gear ratio to again figure this out. So if I look at the velocity, again, the velocity of the edge has to be the same. So RA RA omega A equals then RB omega B. Okay, and I know RA, I know RB, I know omega A. From this, I can then find that omega B equals 10 over 25 times that 1320, which is going to give me 528 radians per second. Again, using that same gear ratio, I can find that theta B is 10 over 25 times 720 radians, and that will give me 288 radians.